So acid, base, and oxides, the different types of oxide. So first one, we have a dilute sulfuric acid, which is a typical acid. A student add an excess of sulfuric acid, means he added more than enough sulfuric acid to a sample of a solid copper 2 carbonate in a test tube. So there is a test tube, and in this test tube, there was a copper 2 carbonate. Copper 2 carbonate is a green solid. And what student did, student add more than enough sulfuric acid, like excess of sulfuric acid or too much sulfuric acid. You have to give three observations. First thing, whenever acid react with any carbonate, what is the product? The product is salt, water, and carbon dioxide. So one thing, the bubbles would form. That's right. There will be phase bubble effervescence. That's the first observation. What about the second observation? Because student add excess of acid. So what will be the result here? Because if too much acid is added, this metal carbonate or a calcium carbonate start to disappear. Or you can also say the solid will dissolve. Actually, it's not dissolving, it's a reaction, but with reference, the metal carbonate. So in this case, the solid will disappear because in the question, they mentioned we add more than enough sulfuric acid, excess of acid. Like if too much acid is there, the solid will disappear. So second point, the solid disappear or metal carbonate, all the metal carbonate dissolve. And because copper salts are there, copper salts are colored solution. Because when copper carbonate is there, not calcium, copper carbonate is there reacting with sulfuric acid, it will give copper sulfate. And copper sulfate salt solutions are blue. So solution will also show a color change. Because if it was a group 1 or 2, it won't show a color change. But here it will form a blue solution because copper sulfate is blue in color. So these are the three observations when acid, sulfuric acid specifically reacting with copper carbonate. Then give name of all the products formed. What are the products formed when copper carbonate reacted with, so copper sulfate, water, and carbon dioxide. And in when you're writing an answer, like you don't have to mention as an equation, you just have to mention the names of the products which are formed. So it will, copper sulfate will be there will be water, and there will be carbon dioxide. So these are the three products which are formed. Sulfate, you can write PHAT or FAT, both are acceptable. In question 2, we have to identify the type of oxides. Some oxides of some elements are listed. You can use them once, more than once, and not at all. Which is the main cause of acid rain? So acid rain is due to acidic oxide. So what are the acidic oxide? We have these all, like carbon dioxide is acidic, sulfur dioxide is acidic, phosphorus, silicon, these are acidic oxide. But the major cause, sorry, is sulfur dioxide, SO2. You can also use screen annotation to answer. It's fine. You can use, if you know the answer, you can use screen annotation, which could give the solution with a pH 14. pH 14 means it should be a basic oxide, and group 1, like metal, like this is a basic oxide, sodium oxide, magnesium, even chlorine oxide is acidic. So Which one is a basic oxide which gives a pH 14? That is sodium oxide. Which is colored. To form a colored, there must be a transition element present. So chromium oxide, the transition element present, so Cr2O3. Which is a major impurity in iron ore, that we will discuss in topic metal, but the answer is silicon oxide. So the answer for this one, that is silicon oxide. Which is amphoteric, as I mentioned. Remember the three examples of amphoteric oxides: aluminium, zinc, and lead, the three amphoteric oxides. And which one is a neutral oxide? The only one example which you have to remember, that is carbon monoxide. So carbon monoxide is a neutral oxide. Amphoteric oxides and neutral oxides are different from each other. What is meant by amphoteric oxide? The amphoteric oxides can react with both acid and alkali, where neutral oxide does not react with or no reaction with acid and alkali, or does not react with neither react with acid nor with alkali. The next one, dilute nitric acid behave as a typical acid in some reactions but not in other reactions. So when dilute nitric acid behave as a typical acid when it reacted with copper to oxide and copper to carbonate. Describe what you would see if an excess of more than enough acid is added to a copper to carbonate. So what are the observations? If copper to carbonate, it's a similar, like the three similar observations what we discussed in the first part. There will be bubble, there will be solid disappear, and one more thing, there will be a color change or it will form a colored solution. Bubbles, the solid will disappear and it will form a blue solution, or you can also mention a colored solution. Because copper to carbonate react with nitric acid gives copper nitrate plus carbon dioxide plus water will be there. Copper nitrate, again, it will be a blue solution or a colored solution. When it react with copper oxide, so what is the observation? You can say color change. A solution show a color change is acceptable. When copper 2 oxide react with nitric acid, it gives copper nitrate plus water. So only no bubbles will be there. The solid will disappear. The solid dissolve or solid will disappear and a colored solution. If you don't specify the color, that's fine. You just mention a colored solution is formed. But remember that is in the case when you have a transition element. If you have group 1, 2, or 3, then there's no colored solution formed. Copper salts are usually blue in color, blue-green. So copper nitrate also is blue in color. Because both cases the product is copper nitrate. When copper carbonate react with nitric acid, the product is copper nitrate plus water plus carbon dioxide. Copper oxide react with nitric acid, give copper nitrate plus water. In the second part, when dilute nitric acid is added, copper oxide is black in color. The copper oxide is a black solid, copper carbonate is a green solid. When dilute nitric acid is added to a piece of a copper and is heated, the reaction takes place. It forms copper to nitrate. The part of a chemical equation for reaction between copper and nitric acid is shown. Complete the chemical equation by inserting a formula for copper to nitrate. First, what should be the formula of copper to nitrate? The valency of the copper is +2 and nitrate is a molecular ion with a valency -1. So what should be the formula for copper 2 nitrate? It's not nitride, it is nitrate. Nitrate means like nitrogen with oxygen. So what should be the formula for copper 2 nitrate?
So Mr. CuNO3 2.
So copper 2 nitrate will be CuNO3 in a bracket and 2. Because it's a nitrate, if it was a nitrite, then copper is +2 and nitrite is -3, then in that case it will be Cu3 and 2. But because it's a nitrate, so nitrate valency is -1. NO3 with a charge -1. Then we have to balance the equation. We can only put the number before copper or here, no other. So what should be the number? Simple way, as I mentioned, simple way to balance is start with oxygen always. So when you check oxygen, there are 4 oxygen here and there are 2 oxygens here. So 4 plus 2, 8. 4 plus 2, 6. And 3 multiplied by 2 is also 6. So there are 12 oxygen on the right hand side. How many oxygen on the left hand side? So 8 multiplied by 3, that's equal to 24. So we want to make it 24 because there are 24 oxygen on the left hand side. So we want to make 24 oxygen on the right hand side. So which number I should place before copper to make 24 oxygen? 6, this I cannot change. 4 and 2, which is making 6, I cannot change. I can only change this number here. What number I should put to make it 24? The sum should be 24. I want I have 4 and 2 here and 6 here. So already I have 6 in this side. I want to make 12. This is 6. I want to make it 12. I want to make it 18 because 18 plus 6 makes 24. So which number I should multiply here to get it 24? So I'll multiply by 3 because 3 multiplied by 6 makes 18 and 18 plus 6 makes 24. So 3, we just have to put 3 here. 3 multiplied by 2, 6. 6 multiplied by 3, 18. 18 plus 4 makes 22 and 22 plus 2 makes 24. So 24 oxygen on the right hand side and 24 oxygen on the left hand side. Then other elements are already balanced other than copper are 3. So we just put 3 here. So copper is also balanced. So this equation is balanced in terms of all the reagents, all the elements or atoms. How this reaction of a dilute nitric acid with copper different from the typical metal with acid. Look, when metal react with acid, what is the product? What are the products when metal react with an acid?
Salt plus hydrogen.
So salt plus hydrogen are the products. But so how this is different? Here we have a metal, it's reacting with acid, it is giving salt, water and oxide of nitrogen. So how this reaction of a nitric acid with a copper different from a typical metal? So typical metal, it gives off. So the typical metals with acid gives hydrogen. But here this is not giving a hydrogen gas. The next question, lead 2 oxide is insoluble, means it cannot dissolve in water. Student, add a solid lead 2 oxide to nitric acid until a lead oxide is in excess. So like student is having a nitric acid. Nitric acid is HNO3. and student is adding a lead oxide and in excess, a metal, so lead oxide is added in excess until no more lead oxide will dissolve. When no more lead oxide will dissolve, all the nitric acid means has reacted. What is meant by the term excess? How we define the term excess?
More than enough.
Yeah, more than enough or more than the required quantity for the reaction. That's good. More than enough, you can simply write more than enough or added more than required for the reaction. That's also correct. How would the student know that lead oxide is in excess? Like how he will identify that he has added enough of lead oxide?
Until no more solid is dissolving.
So no solid dissolve or no more solid. Write a chemical equation. So chemical equation should always be symbolic equation. So lead oxide, first it's until unless they mention a word, otherwise it should always be a symbolic equation. So lead to oxide. What should be the formula for lead to oxide? So lead is +2. And oxygen is group 6 of -2. Who have the same valencies? So lead to oxide formula will be PbO. Plus nitric acid, as I mentioned, HNO3. Metal oxide react with acid, gives salt. Because nitric acid gives nitrate salt, so it will give lead to nitrate. What is the formula for lead to nitrate? So lead is +2 and nitrate is a valency -1. So lead to nitrate will be PbNO3 in a bracket 2 because lead valency is +2 and nitrate is -1. So we cross multiply plus water. So it will be H2O. After writing a balance, after writing an equation, you have to balance. Don't bother about balancing in the first stage. First write the correct formulas, then check the balancing. So we start balancing with oxygen followed by hydrogen, and then we can select any order. How many oxygen do you see? 3 multiplied by 2, 6, and plus 7. Here 3 plus 1. So I have to put number on the left hand side. What I should put? 3 multiplied by 2 plus 6 plus 1, 7 oxygen on my right. And here is 1 and 3. So there are 4. I want to make 7 oxygen on the left hand side. So I'll put 2 here. When we put 2, that makes 7 because 2 multiplied by 3, 6 plus 1, 7 oxygen on the left, 7 oxygen on the right. So oxygen is balanced. What about hydrogen? 2 hydrogen here, 2 hydrogen, so it is also balanced. Lead 1, it's also balanced, and nitrogen 2 and 2, it's balanced. So when you start balancing with oxygen, sometimes when you just balance oxygen, the whole equation is balanced.